Hello. Good evening. I hope you have had a relaxing day today. Did you? But yeah, let us work on chemical kinetics tutorial. I hope you can hear me, right? Without any problem. What do you say? Can you hear me? First, at least say that, will you? Is it possible to hear me? All right. Yeah. Yes. Oh, all of you, right? Okay. So let's start with question number 43. Question number 43. This is our question. 0.01 moles of gaseous A was kept in an evacuated rigid vessel of volume 1 cubic decimeter. 227 degrees Celsius with a small amount of catalyst, really tiny quantity of catalyst. A undergoes dissociation in the following manner. It gives you A gas giving you B and C, B plus C, B gas plus C gas. The concentration of A was measured with time. Results is given in the following graph. You can see concentration versus time is a linear plot. Concentration versus time is a linear plot. A is the reactant. Assume that the order of reaction A and rate is K. Write down an equation to the rate expression. So we can write down that. So we can say rate is equal K times A to the power, A gas to the power, simple A. Okay. So A gas to the power, simple A. So this is what you get. Rate is equal to that. Determine the value of A. So in order to determine the value of A, maybe let us take this parameter there, right? See whether we can get this thing. This is the value. This is what is given. Yeah. Okay. So this is our. Let me change this a little bit more. Yeah. Okay. Anyway, it didn't change much. So this is the value that is given. So you see that there's a constant. It's a constant, like meaning there's a straight line plot. So concentration versus time. If it is a straight line plot, you know the order is usually zero, time and the concentration. If it is a concentration straight line plot, the order is zero. Order is zero. Let me remind you this. Yeah, just to remind this rather than me telling this. So you see, minus rate is equal K times A to the power, let us say N, order is N. How do you get the rate? You get the rate change in the concentration of A over time minus is equal to K times A to the power N. Because it is a reactant, you have to define it using minus. So what is the change in the concentration? Concentration at time t minus concentration at the beginning. Divide by t is equal to minus K A to the power N. Right? If N is equal to 0, if N is equal to 0, you can say AT minus A naught is equal to minus K times A to the power 0 means 1. 1 means if you cross multiply, if you take this time here, you become KT. So you can say AT is equal to A naught minus K time. So y is equal to plus C minus mx If the order is 0, then you would get a point plot like this. This is your time. This is your concentration, AT, and it's a straight line plot just like that, where this is your A naught, initial concentration. So here we see a straight line plot, isn't it? So you can say it's a straight line plot, straight line plot for concentration versus time, and therefore A is equal to 0. If it is 1, you get a curve. If it is 2, also you get a curve, right? You get a curve like that. If it is 1, this is order is n is equal to 1. Order is if n is equal to 2, you get another curve, different curve, right? So this is n is equal to 0, right? Concentration versus time. I hope you understood that. And then determine the value of A is equal to 0, right? Then they say third one, calculate the rate constant. How do you get the rate constant here? You can see AT minus A naught divided by time is equal to minus K. A to the power 0, right? A to the power 0 means 1. A to the power 0 is 1. So since you have a minus sign, you can say A naught divide minus AT divide by time is equal to K. So let us take a value. A naught is 0.010. 0.010 minus 80. Select a time. Let us say this is 1000. 1000 is somewhere here. What is our value? Value is 0.006. 0.006. Time for this. Time is you have spent 1000 milliseconds, 1000 seconds. So divide by 1000. Unit is seconds. Here this is moles per cubic decimeter is equal to K. So what is K? K is equal to 0.010, 0.004. 0.004 divided by 1000, that will give you 4 10 to the power minus 6 moles per cubic decimeter per second. Balanda Puta, did you whether you got that answer? Right? Did you all get those answers? Can you please tell me? Huh? Did you all get these answers? කියන්න බලන්න. ටක් ගාලා දාන්න ඕක yes කියලා හරි no කියලා හරි දාන්න පුළුවන්. ඕක එච්චර අමාරු දෙයක් නෙවෙයිනේ. Please give me an answer, feedback. Four 10 to the power minus 6. Is it clear? Yeah, okay, right, Hari. So that is at 227. Then it says, question number 4, the part 4, it says, calculate the pressure inside the container. Calculate the pressure inside the container. Calculate the pressure inside the container. If half of the initial amount of A has dissociated, ignore the volume of the catalyst. So you have A gas giving you B gas and C gas. Make a rice chart. C gas. So our concentrations are at the very beginning 0.01 moles. There's nothing here. Half of it has reacted. Half of it has reacted means 0.005 has reacted. 0.005 moles has reacted. plus 0.005. This is also plus 0.005. So at the end, you see this kind of a reaction, 0.005 here. This is also 0.005 and this is 0.005. What is the total amount? Total amount is equal to all our gases, no, 0.015 moles. This is the number of moles. So what is the pressure? Pressure is equal to PV is equal to nRT. nRT divided by V. Number of moles is equal to 0.015 moles. But double check, right? R is equal to 8.314 joules per moles per Kelvin. And temperature is equal to 226, 273, 500 Kelvin. What is the volume? Volume is equal to 1 cubic decimeters, 1 10 to the power minus 3 cubic meters. So you can see some of these units cancels out. And you would get 0.015 times 8.314 times 500. Divide by 1 10 to the power minus 3. What is the answer? 6.235 10 to the power 1, 2, 3, 4 pascals. Is it clear? Did you all get that? Right? Yes. Okay. Thank you. So question number 43 is done. Question number 43. I think you are okay with that. Balamu, let us go to question number 44 also. Right? Yeah. Okay. Question number 44 as well. Right. So let's look at question number 44 in page number 18. Question number 44. Right. X undergoes thermal decomposition in the presence of a solid catalyst as shown below. Right. So there is a reaction X gas. It's breaking down to two X නෙවෙයි. ඒක මම අපි ගමු 2Y කියලා දාමුකෝ ඒක. Y gas and Z. You can't have X there නේ. My typing mistakes ඒවා සමහර ලාට I have never recognized them. Right. 1 mole of gaseous X, is kept inside the complete evacuated container of volume V0. So 1 mole, you keep it in a volume V0. The volume of the catalyst, which is negligible, very tiny amount of the catalyst, it's negligible, has been used to start the reaction. You begin the reaction using that. Rate constant of the catalyst reaction is K1. So rate constant is K1. Rate constant is K1. And the order with respect to X is B, right? So order is B. Initial rate of reaction has been measured as R naught. So when you look at the measure rate, R naught is the rate that you get. The container was allowed to get expanded to keep the pressure inside the inside the container constant. So pressure is constant. The temperature of the system is also kept constant. Temperature and the pressure are constant, right? And it is allowed to expand. Write down an expression for R naught using B, K1 and V naught. So you know rate is equal to K times concentration of X gas to the power, the order is given. Order is B, right? Okay. So rate is R naught. Rate constant is K1. Concentration is, what is the concentration? You have 1 mole here and then divide by V naught is the volume. V naught is the volume that is given to the power B. So I think that is your answer, first one, right? Write down the expression B, K1 and V naught. 1 mole, right? Right. Second one, it says, it was noted that 50% of X is consumed. 50% is of X is consumed. So X, now you have 0.5 moles. 50% of X is consumed. X is consumed, the volume of the container has doubled. So now the volume is, what is the volume? volume is 2V naught, doubled. And the rate of the reaction is 0.25. Rate is equal to 0.25. 0.25 R naught. Calculate the order B for the reaction. So let us look at the rate here. Rate is 1 over 4 R naught. 0.25 means 1 over 4 R naught is equal to K1. Now the concentration is 0.5 moles because 50% has consumed. So remaining 50% is what we are looking at the concentration as right now. And the total volume is 2V naught. 2V naught and to the power B. This is equation 1 and this is equation 2. So what you do? You take that and maybe divide and try to get that answer for 1 and 2 division. So you get R naught divided by R naught over 4 is equal to K1. K1 cancels out. 1 over V naught to the power B divided by 0.5. 0.5 means 1 over 2. No? 1 over 4 V naught to the power B. So V naught and V naught cancels out. R naught and R naught cancels out. 4 is equal to 4 to the power B. B is equal to 1. Is it clear? Calculate the order of B. Everybody got that? We can. Right. Thank you. Okay, Nene. Right. Got the same. Right. Thank you, Niyamai. Good. Now, question number 45. Question number 45. Kinetics of a chemical reaction may be studied using the initial rates of reaction. So their rates are given, right? These 4 reactions given in the table below. Experiments carried out by changing the concentration of reagents A, B, C, and the concentration delta A naught has been measured with time. Calculate the rate once, right? Change in the concentration is given and the time is also given. So how I calculate the rate using change in the concentration of A over time. First one, rate 1 is equal to, what is that? 0.040 divided by 50. 50. What is the concentration? Moles per cubic decimeter per second. 0.040 divided by 50 is equal to 810 to the power minus 4. 810 to the power minus 4 moles per cubic decimeter per second. Right? Rate 2. What is rate 2? 0.096 divided by 60 moles per cubic decimeter per second. 0.096 divided by 60 again 1.6 10 to the power minus 3. Thank you very much for the answer. Thank you. Niyamai. 10 to the power minus 3 moles per cubic decimeter per second. Rate 3 is 0.128 divided by 40. Don't forget the unit when you are doing those calculations. Right? What is that? 0.128 divided by 40 is equal to 3.2 10 to the power minus 3. Right. 3.2 10 to the power minus 3 moles per cubic decimeter per second. Right. And then R4 is equal to, what is that? 0.080 divided by 25 moles per cubic decimeter per second is equal to 0.080 divided by 25 is equal to 3.2 10 to the power minus 3. 3.2 10 to the power minus 3 moles per cubic decimeter per second. Is it clear? Those answers are okay? Right, good. I hope all of you got those answers. Right. Complete the table. Calculate the orders of A, B, C and calculate the rate constant K. Write down the rate expression using those values. Sorry. So first of all, we have to substitute this. They have given A, B, C as the orders, right? So let us say rate is equal, I write this equation, rate is equal K times concentration of A to the power simple A, concentration of B to the power simple B, concentration of C to the power simple C, right? First one, 8 10 to the power minus 4 moles per cubic decimeter per second is equal to K times, what is that? 0.2 moles per cubic decimeter to the power A, right? Then 0.2 moles per cubic decimeter to the power B, and then 0.2 moles per cubic decimeter to the power C, equation 1. Correct? Next one. Rate is equal to 1.610 to the power minus 3. 1.610 to the power minus 3 moles per cubic decimeter per second. This is the most annoying part. Make it 0.4 moles per cubic decimeter per second. A, not second, 0.2 moles per cubic decimeter to the power B. And then next one is 0.2 moles per cubic decimeter to the power C, second one. Next one is 3.2 10 to the power minus 3, 3.2 10 to the power minus 3, both are like that. 3.2 10 to the power minus 3 moles per cubic decimeter per second is equal to K times 0.4 moles per cubic decimeter to the power A, 0.4 moles per cubic decimeter to the power B, and the other one is 0.2 moles per cubic decimeter to the power C. This is the third one. Next one is also 3.2 10 to the power minus 3 moles per cubic decimeter per second is equal to K times, what is that? 0.2 moles per cubic decimeter A, 0.2 moles per cubic decimeter B, and then the other one is 0.4 moles per cubic decimeter C. They look like Chinese letters. Anyway, how do you find A? The easiest way to do it is 2 divided by 1. 2 divided by 1. It gives you 2 to the power A is equal to 2. Therefore, A is equal to 1. Next one, what is the easiest way to do it? 3 and 2. 3 divided by 2. So 3.2 10 to the power minus 3, 1.6, that is 2. 2 to the power B is equal to 2. Therefore, B is equal to 1. And then let us see what is the easiest way to solve this one. 0.4, 0.4. Yeah. Anyway, we have to divide. Let us say 4 divided by 3. 4 divided by 3. 3.2 10 to the power minus 3. 3.2 10 to the power minus 3. So 1 is equal to upset 0.4 divided by 3. So 0.2 divided by 0.4 half. Then 0.2 divided by 0.4, that is also half. 0.4 divided by this is equal to 2. 2 to the power C. Got 4 is equal to, make a couple right? 4 is equal to 2 to the power C. C is equal to 2 then. Is that what you get? Right? Okay. Hari, come on. So A is equal to 1, I hope. But tell me whether these answers are right. A is equal to 1, B is equal to 1, and C is equal to 2. These are the answers I got. Yes, Hari, thank you. Right. Determine the overall and calculate the rate constant. How do you calculate the rate constant? Let us substitute one of these things. I think if you substitute this into the first equation, it will be easy. 8 10 to the power minus 4 unit is moles per cubic decimeter per second. Moles per cubic decimeter per second is equal to, what is that? 0.2, 0.2, 0.2. So 0.2 moles per cubic decimeter to the power 4 times K. So what is your rate constant? Rate constant is 8 10 to the power minus 4. So 16 10 to the power minus 4. Unit is dm9 moles minus 3 per second. No menne. But double check. 0.5 the kela. 0.5 dm9 moles minus 3 and per second. What do you say? Do you agree with that? Right. Okay. Good. So determine the overall order of the reaction. Overall order is equal to what? How much is that? Overall order, add everything together. Overall order is 4. Right. Right. Nearby. Good. Let us look at part B. Part B also, let's try to read that and try to work it out. In another experiment, concentration of A naught is 110 to the power minus 3. B naught is 110 to the power minus 3. C naught is 2 moles per cubic decimeter. Show that the rate expression can be written as K dash A to the power A. Right. So concentration of B naught is very large, right? 1 moles per cubic decimeter. Concentration of C naught is also very large. That means throughout this reaction, it looks like that the concentration doesn't change. It's not going to change much, right? So you can say rate is equal to, what is that? K A to the power 1, B to the power 1, C to the power squared. This is a constant. C is also a constant. So they are constants. So now you can say rate is equal K dash times A to the power A, but you know A is equal to 1. K dash, what is K dash? K times concentration of B times concentration of C to the power 2. K dash. This is your K dash. But now what has happened is throughout the entire reaction, the concentration of B and concentration of C doesn't drastically change. So therefore, it looks like a first order reaction. So what is this kind of a reaction called? What is that kind of a reaction called? Oh, namak, there's a name for it, special name. What is that special name? What kind of a reaction is that? What is that called? When it actually is order 4, but looks like order 1. Very good. It looks like order 1. It's a fake reaction. It's a fake order. So you call it a pseudo first order reaction. Make a unimolecular නෙවෙයි. Right? It's a fake reaction. Or a pseudo first order reaction. Pseudo means fake. PSCUDO. Pseudo first order reaction. It looks like a first order reaction, but it is not really a first order reaction. Yeah, sometimes it looks like very helpful, but they are not really helpful. Very upset කරන්න තමයි ඉන්නේ. So likewise, this is like a first order reaction. It looks like a first order reaction, but this is actually not a first order reaction. It's a fake first order reaction. Fake, in science, you call it pseudo. Right? Right. So then it says, constant. What are the assumptions you made when writing the above expression? What are the assumptions that you make when you write in the expression? There are two assumptions. First assumption is concentration of මොනවද? Concentration of B and C does not change. Does not change. ඔන්න පළවෙනි assumption එක. That is the first assumption. What is the second one? Second one is the mechanism does not change. Mechanism has not changed. Mechanism has not changed. Is it clear? Did you understand that? Concentration doesn't change, but then mechanism also cannot change, because otherwise you can't take it as order number one. Order cannot be taken as one. Did you understand that? What තේරුණාද? I hope all of you got the idea. So mechanism has not changed and the concentration has not changed. The concentration of A of the reaction above changes with time according to the following expression. They have given this equation 2.303 log 10 A is equal to K dash T plus 2.303 log 10 A naught. A naught is the initial concentration of A. Show that the half-life of the reaction is given by this value. Calculate the value of T half using the data you obtained above. So what is that? Kt is equal to K dash T is equal to 2.303 log 10 A divided by A naught. Like, subtraction means log division. Subtraction is log division. What is that? I can't see this. Yeah. Can you please explain again pseudo? Pseudo क्या क्या fake කියන එක එච්චරයි. ඒකේ මොනවත් explain කරන්න දෙයක් නැහැ. There's nothing to explain there. Pseudo means fake. Like, if you look at this, it looks like a first order reaction. Actually, it's not a first order reaction. In the rate determining step, 4 molecules collide with each other. But since the concentration doesn't drastically change, it's not a fake reaction. It's a reaction, actual reaction. But the number of molecules that is participating in the reaction, rate determining step, it looks like 1. Actually, there are 4 molecules participating. Alright? Kt is equal to log A divided by A naught. Right? Again, the Kt, K dash T is equal to 2.303 log 10. A means A naught divided by 2. A naught. With half-life. So this and this cancels out. Yeah. So K dash T is equal to 2.303 and log 0.5, log 10.5. බලන්න හරිද කියලා log 10.5 නම් වෙන්න බෑ ඒක. You get a minus value. Log 0.5. Yeah, 0.5. Might be minus KT, නේද? 2.303, this should be minus, I think. If it is minus A divided by A naught, A divided by A naught means A naught divided by 2, and this is minus 0.3010. Minus, it should be minus KT. So this is T half. T half is equal to minus 2.303 multiplied by 0.3010, I think. Divide by K dash. Make it minus, So that will give you plus. 2.303 multiplied by 0.3010. It was 693. Is it clear? 693. Let me check. Let me check. I might have written it earlier also. I have given a similar question earlier as well. Yes. Log 2.30. Yes, yes, yeah. If you look at question number 39, you can see that. Typing it should be minus. Right? I will correct that. Minus KT, it should be. Calculate the value of T half using the data you obtained above. So what is the data that we obtained there? Calculate the value of T half. Okay, so what is K dash? K dash we can calculate. K dash is this value. Here, look at this one. This is K dash. K dash is this. K dash is equal to K times concentration of B, concentration of C squared. K you have calculated earlier. What is K? 0.5. 0.5. What is the unit? DM9 MOL3 minus. DM9 MOL3 minus per second. Concentration of B. What is the concentration of B that you get? What is the concentration of B? We maintain at a constant value. Concentration of B is 1 moles per cubic decimeter. 1 moles per cubic decimeter. Concentration of C, this one, we maintain at a constant value, that is 2 moles per cubic decimeter. 2 moles per cubic decimeter squared. Units cancels out, right? And you will end up with per second. What is that? 4. 4 times 5 is 2. 2 per second. So what do they ask you to calculate? T half. T half is equal to 0.693 divided by 2 per second. Unit lesson 0.693 divided by 2. Double check your answer and tell me whether you got the same answer. 0.347 seconds. Is that what you get? Anybody got those answers? Can you confirm? Right, okay. 3, 4, or 6, 5 kila dino. Right, okay, good. I hope all of you got that. Correct, it should be minus, otherwise. Right, okay. Shall we look at the next question also? Question number 46. Question number 46. If you're okay with that, let us look at question number 46. It says, hydrogen gas is used to reduce NO into nitrogen. So there's a reaction that is there. The experiment was carried out at 900 degrees to produce the following results. No results. Like, yeah, I noticed that, column number 4, it's like the same as the column number 3, but the different rates. So we will use 1, 2, 3, only the 1, 2, 3 and try to do the calculation and see. I don't know whether it is giving you the right answers. Double check, right? Rate is equal K times hydrogen gas to the power A, NO gas to the power B. As soon as you write this expression, what is the first thing that you should do? We have to define the terms. K is the rate constant, rate A is the order with respect to hydrogen, B is the order with respect to NO, right? And then let us write down these expressions. 0.0248. moles per cubic decimeter per second is equal to K times 0.212 moles per cubic decimeter to the power A. It was a 0.136 moles per cubic decimeter to the power B. Equation 1. And second one, 0.0991. Say moles per cubic decimeter per second is equal to K times 0.212 moles per cubic decimeter A 0.272 moles per cubic decimeter to the power B. Next one is 0.793 moles per cubic decimeter to the power per second. K times 0.424 moles per cubic decimeter and 0.54544 moles per cubic decimeter to the power B. I'm not going to substitute the third one. It looks like you can see that concentrations is the same, but the rates are different. So I feel like that I might have typed it wrong. But I think we should be able to get this thing. Don't know whether this will give you the right answer. Let us check. 2 divided by 1. 2 divided by 1, 0.0991 divided by 0.0248 is equal to 0.272 කියලා කියන්නේ 2 to the power b නේද 2 to the power b 136 0.0991 divided by 0.0248 කීයක් දෙන්නේ 3.99 I think 2 to the power b is equal to 4 therefore b is equal to 2 right අපි දැන් බලමු 3 divided by 2 also will try 3 divided by 2 0.793 divided by 0.0991 is equal to 2 to the power A times 2 to the power B. 0.544 divided by 0.272 is 2. 2 to the power 8. So what is that? 0.793 divided by 0.0991. What is that? It gives you a value of 8. 8 is equal to 2 to the power A multiplied by, this is 2 to the power 2. That is 4. Therefore, A is equal to 2 again. No, 4. No, 4. Yes, 2. Is that what you get? No, 2 to the 1 වෙන්නදී. I think 1 might be. 2 to the power 1. What is your answer? 1, yes. A is equal to 1. Oh, 2 to the power 1. A. 1. 2 to the power 2 plus A is equal to 2 to the power 3. 2 plus A is equal to 3. A is equal to 1. Is that clear? Derive the rate equation. So what is the rate equation? Rate is equal to K times, what is that? Hydrogen to the power 1. Hydrogen gas to the power 1. What is the other one? Nitrogen monoxide gas to the power 2. Is that clear? Right. Calculate the rate constant. You can calculate the rate constant. Rate constant, let us substitute it to the first one. Right? 0.0248 moles per cubic decimeter per second. Hydrogen concentration. What is the hydrogen concentration? 0.212 moles per cubic decimeter. And 0.136 moles per cubic decimeter to the power 2. So this and this cancels out. So you get dm6 mol2 minus and per second. What is the value? 0.0248 divided by 0.212. This is divided by 0.136 squared. What is the answer? 6.32. 6.32 is the answer that I got. Is it okay? Right. Good. Excellent. Nearby. Everybody okay with that? I hope all of you got those answers. So that is question number 4. Why last column you can remove, huh? Yeah, you remove the last column. Make like cut and paste make. So next week we'll do the other ones. Question number 47 indala. We'll try question number 47 indala. Let's look at up to 47, 48, 49, 50, 51, 52. Question number 47 to 52. If you do that, then very soon I might have to get rid of this tutorial also. Right? So let's next week we'll look at 47 to 52. Right? I want you to please try and do them. 52. Next week, and we'll discuss those answers. 53, 54 also we will discuss. Like I'll maybe another 2 weeks with make a karano, right? We can try to finish. And then if you move forward and if there are any difficult questions that may we can discuss as well. Did I ask you to do question number 47 as well? 47 we can do that. Is it? Yes, we'll do. Okay, right. Question number 47 as well then. 47 right? So that you can complete that page. Right, nitrogen monoxide and hydrogen react with each other as shown at 700 degrees Celsius. So this is some data obtained are given below. NO is given like that, right? Initial rate is given like this, right? And these ones are also given. What is meant by the order of the reaction? What is meant by the order? First one, this is the what is order? Order is how the concentrations of reactants depends on the rate determined using an experimental method, right? Molecularity is the theoretical one. When you look at the mechanism and study, order is how it depends based on the experiment. So let us write down. This is how the rate of a reaction depends on the concentration of reactants measured experimentally. Is it okay? Do you want to add anything to this? What did you write? Order of a reaction is that how it depends on the rate of the reaction measured experimentally. Calculate the order with respect to NO. Calculate the order with respect to hydrogen. So let us look at the maybe first two experiments. First experiment and the second experiment, Balan. First one and the second experiment. First and the second experiment. Rate is equal to K times, what is that? Hydrogen concentration to the power A, NO concentration to the power B. Now, if you look at the first one, rate is equal to 0.033 moles per cubic decimeter per second is equal to K times hydrogen concentration is 0.012 A. NO concentration is 0.002 B. Equation 1. Right. Second one balan, third one balan. 0.003 third one. I am not sure whether the second line is right or rate but let us do this. Third 0.03 moles per cubic decimeter per second is equal to K times 0.012 moles per cubic decimeter. A, the other one is 0.006 moles per cubic decimeter B. Alright? Then double check this second one. Right. So what do you get? Second one, right? 2 divided by 1. 0.03 divided by 0.033 is equal to another 0.03 to the power B. What is that? 0.03 divided by 0.033, yeah, like, roughly equal to 1 is equal to 3 to the power B. B is equal to 1. Right? What do you think? Is it okay? Did you get that? And if you look at the next one, if you look at the question 4 and 6, 4 and 6, did you get that? Yeah, B is equal to 0, 0, yes. Yeah, 1, yeah. Oh, sorry. B is equal to 0. Should be, yeah, 0. Right. Yeah, you're right. B is equal to 0. Question number 4 and 6, if you look at it, what do you get? Rate is equal to 0.006 divided by 0.02 moles per cubic decimeter per second. Moles per cubic decimeter per second is equal to, what is that? NO is a constant, 0.006 divided by 0.002 to the power hydrogen to the power A. So this and this is 3. This and this is also 3. 3 to the power A is equal to 3. Therefore, A is equal to 1. Is it okay? A is equal to 1 and B is equal to 0. බලන්න හරිද කියලා? What do you think? Can you confirm? Right, yeah, okay. Then it says using the results obtained 2 above, write the rate expression for the reaction K as the rate constant. Rate is equal K times what? K times what is A? A is equal to 1. A is equal to hydrogen gas. Hydrogen gas to the power 1. You don't have to say 1, nah? Just have to write that. Calculate the value of the rate constant K. So let us use one of these data and then we'll try to work it out. Balamu, fourth one. Fourth one. You can substitute to any place that you like. Rate is 0.02. moles per cubic decimeter per second is equal to K times hydrogen concentration. What is the hydrogen concentration? 0.002 10 to the power minus 3 moles per cubic decimeter to the power 1. Make a cancel now. So K is equal to 2 10 to the power minus 2 divide by 2 10 to the power minus 3 per second. So all cancels out 10 to the power minus 1. That will be 10 per second. What do you say? Did you get that, children? Huh? Yeah, okay, good. Explain the increased rate, constant value, 5. Explain the reason for the increased rate of reaction when the temperature is increased. There are two things. Always, whenever the temperature is increased, there are two things. First one is the number of collisions increase. Number of collisions increases. And the second thing that will happen is the fraction of molecules overcoming the activation energy barrier increases. Increases as well. So because of that, you see that there's an increased rate of reaction. Is the reaction above, is it exothermic or endothermic? Give reasons. The hydrogen, NO, H2O and nitrogen. What do you think? Is it a exothermic reaction or endothermic reaction? If you look at hydrogen, this is hydrogen. NO is this, giving you H2O. And then you get nitrogen also. So you can see there is a very strong bond is formed. You are breaking a weak bond. And you are forming a very strong bond. So what would happen? There is great amount of energy should be given out. So therefore it should be a exothermic process. Right, very good. So it's a exothermic process. Because nitrogen is formed, it's an exothermic process. Right, so you can say a stronger bond, triple bond is formed. Therefore, this gives you a exothermic process. Hari. Now, question number, right now, next week, question number 48, I'm not going to discuss, right? Because it's very similar to earlier calculations. So similar. 49, I will discuss 50, 51, 52. अभी 53 discuss करूँ because there's a pH one there. Now you know pH, you can do it better. You have a better idea of pH. So we will look at මොනවාද මම කරන්නේ දැන් next week. Now question number 47 also we have discussed that. හරි. ඒක හරිනේ. එහෙනම් we discuss question number 48. I am not going to work out. But if you feel like that it is difficult, why is it exothermic? Because a triple bond is formed. It's a very strong bond. Right? No, you're breaking a double bond, weaker bond. This one is also a single bond, weaker bond, right? And here you are forming two bonds and you are forming three bonds. Like, it's a triple bond. Triple bonds are stronger, right? So it gives out energy. Is it clear? So for question number 48, I won't discuss. ඒක ඕනේ නැහැ. Because it's very similar questions. But 49, 50, 49 I will work on, 50 I will work on, 51, 52, and maybe 53, 54, 1, 2, 3, 4, 5, 6, 54. Let us say 55 also. Next week. So next week, please work on these questions in the tutorial. These questions in the tutorial for the next week. මමත් නිකන් මාක් කරගන්න up to 54 ද 54 කියලා කිව්වද මම 55 up to 55 right okay so we will discuss එච්චර පුළුවන් නේද අපිට 49 47 we have discussed so 48 we are not going to discuss and 49 50 51 52 53 54 and 55 එතෙන්ට නිකන් කරන්න right and another week we will discuss one another week හරිද එතකොට ඔයා මේ ටියුට් එක කරලා whatever the difficult ones you can ask එතකොට මම ඒක we will discuss them if you have more time we will discuss others හරි now we shall we go to the acid chloride ones acid chloride tutorial right so let me take a picture so that we can work on that page itself acid chlorides right let us add this thing okay so what are your answers we will discuss those first 3 pages right what are your answers 1 2 3 what are the what is the answer let me change this also little slightly so that you get a kind of a better view of this hurry what is the answer can balance what is the meth eth prop and if it is a benzoyl chloride you call it propanol chloride prop an oil space chloride is it okay මම නිකන් කියන්න ඕනේ ඔයාලා මේක this is okay ද නැද්ද කියලා like if you have done it please tell me all right okay අන්න හරි right okay ඉතින් 1 2 3 4 5 what is that 3 methyl what is that pentanoyl chloride බලන්න හරිද කියලා right pentanoyl chloride 3 methyl pentanoyl chloride thank you හරිද so next one 1 2 3 4 කියන්න බලන්න පුතා 2,3 dimethyl what butanoyl chloride හරිද right next one 1 2 3 4 5 මොකද්ද පුතා ඒකේ නම what is that 2 chloro 3 pent an oil chloride pentanoyl chloride හරි 1 2 3 4 5 6 7 කියන්න බලන්න what is the name mn නේද right 6 methyl m methyl what 2 nitro what 2 nitro 2 hept an oil chloride if there's a mistake you need to tell me right so this is that name what about the name here what is the name there 1 2 3 4 5 6 7 what is the name 4 bromo 4 bromo then what is the next one 5 ethyl. 5 ethyl. Then 3 methyl. 3 methyl what? Hept. An oil chloride. මොකද කියන්නේ? 4 bromo 5 ethyl 3 methyl heptanoyl chloride. මේක 1 2 3 4 5 6 7 8. Can you tell me what is that? 5 heptanoyl. Heptanoyl. මොකද්ද? You have written 2 heptanoyl. Hep 3 heptanoyl. 3. Yeah. So in the second position, you get the double bond. Double bond. Which one is are you talking about? 3 heptanoyl කියලා කියන්නේ කොකද? No double bond. Right. Okay. So 8. What is the name? This is the longest continuous carbon chain is this, ne? Starting from here goes up to that point. Question E. 1 2 3. 6 methyl. We are looking at question number E. 6 methyl, 2 nitro, 3 heptanoyl. 3 heptanoyl. So look at the longest continuous carbon chain. So that is 5 ethyl. 5 ethyl ABC. 5 ethyl. What is that? Chloro. 2 chloro, alphabetical order. 2 chloro, 5 ethyl, MNO, 2,6 dimethyl, 4-oxo, octanoyl chloride. Octanoyl chloride. This is the name for this one. Then we look at this one. What is the name? 1 2 3 4 5 6. Put 2 amino A B C D E F G H I J K L M 2 methyl 5 oxo 3 hexan oil chloride. This one is the next one. This is the longest continuous carbon chain is that. Let us write down the name. Tell me, right? 1 2 3 4 5 6 7 8. Can you put the What is that? 7 chloro. 7 chloro. You say 2 2 dimethyl. 2,2 dimethyl. 2 2 5. 2 2 5 trimethyl. 2,2, 5 trimethyl. Trimethyl what? Oct. An oil chloride. Octanoyl chloride. Harida. And the last one is this one. Well, double check whether I have done it right. This is the right. This is our equation 1, 2, 3, and 4. Manada. I put a star here and write it. What is the name? 2 bromo. What else? 2 formyl. 3 hydroxy. And 3 methyl. Butanoyl. Chloride. Right. So these are the answers to the first page. Right. Please check whether these are okay. If you are okay with that, I can we'll go to the second page. Any doubts, any things that you feel like that it is not correct? So, ETH question. මොකක්ද ඊවල? ඊවල තියෙන්නේ මොකක්ද? Yeah, it's like 1, 2, 3. මොකක්ද ඒකේ ප්‍රශ්නේ? 6, 7. හරිනේ? 6 methyl, 6 methyl, and then 2 second position nitro, altogether hept, third position N, oil chloride. හරිනේ දැන්? Now okay, right? Earlier I said 2, ඒක වැරදි. 3. Now okay, I think, yeah. Did you check your answers? Can බලන්න anything that doesn't tally with your answers? මොකද පුතා කියන්නේ? Everybody okay? Children? What do you say? Did you all get that? I want your confirmation on this. Anything that you want to correct? Now okay? Everything all right? Hari, right. Honey, thank you. Right. Okay. Question number 2. Okay, first one, it says ethanoyl chloride. Ethanoyl chloride means you have carbon, 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 C double bond O Cl. All the others are hydrogens. Ethanoyl chloride is that. Propanoyl chloride, ethanol, ethanol is that. Propanoyl is carbon, 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 double bond oxygen, Cl. This is the second one, right? Benzoyl chloride. Third one. Benzoyl chloride is benzene. You get C double bond O Cl. Benzoyl chloride is that. Fourth one, butanoyl bromide. 1, 2, 3, 4. C double bond O Br. 1, 2, 3. So the butane double bond here. All the others are hydrogens. Right? Fifth one, 2 bromo 3 ethyl hexanoyl bromide. 1, 2, 3, 4, 5, 6. 2 bromo. Methano bromine. 3 ethyl. Carbon, carbon. Hexanoyl. hexanoyl bromide. Again, first carbon COBr. Everything else is hydrogen. බලන්න 3 ethyl. This is CH2, CH3. එතකොට මෙතන H එකක් එනවා. There is a hydrogen here. This is CH2. This is CH2. This is CH3. Sixth one, 3,3-dimethyl 4-oxo-hex-2-enoyl chloride, right? 1, 2, 3, 4, 5, 6. No? First one is chloride. 3,3-dimethyl, 1, 2, 3, CH3, CH3, 3,3-dimethyl. 4-oxo, 1, 2, 3, 4, 4-oxo. Hex 2N. In the second position, 1, 2, second position, double bond. එතකොට එක වැරදිනවා. This structure is wrong, right? It violates the octet. So 1 and 2, so you can't have that, right? Seventh one, 2-bromo, 2,3-dichloro, 4-ethyl pentanoyl chloride. 1, 2, 3, 4, 5. Pentanoyl chloride, OCl. 2-bromo, Br. 2,3-dichloro, chloro, and this is also chloro. 4-ethyl, 1, 2, 3, 4. CH2, CH3. Pentanoyl chloride. This is also CH2, CH3. No, complete. Eighth one, 2-chloro, 4-nitro, 3-oxohexanoyl chloride. 1, 2, 3, 4, 5, 6. 2-chloro, 4-nitro, 3-oxo hexanoyl chloride. O, මෙතන Cl. මෙතන H. මෙතන H. CH2, CH3. 8. 9. 3-amino, 2,3-diethyl hept 2-enoyl bromide. 1, 2, 3, hept 4, 5, 6, 7. 3-amino, NH2. 2,3-diethyl, CH2, CH3, CH2, CH3, diethyl. Hept 2N, 1, 2. Upset 2N enoyl chloride. Right here, the octet is not completed. It violates the octet. We double check if there is any mistake. Question number 10. 4,4-dibromo, 3-formyl, 2-oxo, 5-heptanoyl chloride. Hept means 7 carbons. 1, 2, 3, 4, 5, 6, 7. Heptanoyl chloride, OCl. 4,4-dibromo, 1, 2, 3, 4, dibromo. 4,4-dibromo. 3-formyl, 1, 2, 3, 4-myl. COH, 4-myl. 2-oxo, 2 double bond oxygen. 5-heptine, 1, 2, 3, 4, 5. මෙතන heptine oil chloride. බලන්න මොකද කියන්නේ කියලා. Whether your structures are okay. Did I get them right? Could you recheck 7th structure? 7th structure. Let us double check. 7 chunk. 5 plus 5, 2. 2-bromo. This is 1. This is 2. This is 3. This is 4. This is 5. 2-bromo. Bromo. 2,3-dichloro. 2 and 3-dichloro. 4-ethyl. 4-ethyl. Yes. This is 3-ethyl I have drawn. 4-ethyl it should be. Thank you. This is 4-ethyl. CH2, CH3. Right? 4-ethyl pentanoyl chloride. Then what will happen is, we have taken the wrong length. This is the longest continuous carbon chain. So if it is the longest continuous carbon chain, we should name it differently. 1, 2, this is 3, 4, 5, and 6. What is the name? 2 bromo, 2, 3 dichloro, 4 methyl, hex, and oil chloride. Right? So you have to say name is wrong. Name is wrong. Karaned. Anything else to check? Anything else to check? All others are okay. Anything else to check? Anything else that you want to look at? Right. Haridhan. Silence means you're okay. Clear? Then shall we look at the next set of questions? Hmm? Next set of questions, we'll look at that as well. Huh? Right. Okay, so what do you say? First one, we'll look at some of those answers. CH3CH2 COCl, CH3 CH2OH. When you add this together, it gives you what? What is it giving you? It gives you an ester. CH3, CH2, C double bond O, CHO, CH2, CH3. This is the best way to form esters. Right? And these both are the same, no? This and this both are the same. It gives you the same answer. Now, if you add sodium hydroxide, what will happen is this bond breaks and the structure remains the same. Only thing is it turns into a CH3H. This is CH3. But remember, when you add sodium hydroxide, it gives you the carboxylic acid salt, ONA. Not the carboxylic acid. It gives you the carboxylic acid salt. Kian Balan, whether you are okay with that? Children, tell me whether you are okay with those. Right? When you add water, what will happen? It hydrolyzes and it gives you CH3, CH2, C double bond OH. Children, see whether this is okay. CH3 MgCl excess. Excess means it adds again and again. CH3 attacks onto this, break the bond, comes back, leave, and another CH3 attacks. So you get two CH3s hooked into that oxygen. So what is that? CH3, carbon CH3. This is also CH3. And then you get CH2. C, this gives you OH. There's a CH3 on this side. There's a CH3 on this side. Right? Please tell me, whether they are okay. C2H5MgCl, again the same mechanism. Only thing is you get C2H5, two of them. attached to this CH3, CH, CH3, CH3. And then what will happen is you get COH, and here you get CH2, CH3, and also CH2, CH3. So, whether the other answers are okay. And if you add NH3, it gives you the amide. That is the best way to form amides. So you get CH3, CH, CH3. This is also CH, CH3, and you get C double bond O, NH2. And you add a primary amine that also gives you a substituted amide. CH3, CH2, C double bond O, NH, CH3. If you want any of their mechanisms, please tell me. Any of their mechanisms. Please go through those structures, check whether the structures are okay, and if you want to study any of those mechanisms, now just to recheck them, like just to remind you, anything, any mechanism do you want? Any mechanisms you want to discuss here? If it is okay, Grignard and the acid chloride. Grignard and the acid chloride is this CH3. If you have C double bond OCl, R, MgBr, make this is delta plus and this is delta minus. This is delta minus and this is delta plus. And attacks onto this, break the bond. So you get CH3, CO minus Cl, and you get R. This one, Cl, is a good leaving group, and it will react. And it gives you a ketone. Now, ketones, now all the molecules, Grignard molecules, will react with the acid chloride and it turns into the ketone first. But then there's excess Grignard. So that excess Grignard will react with the ketone as well. Right? And then you get CH3, COH, you get R, and you get R. Actually, you get MgBr here. When you add H plus H2O, it will vanish. This will vanish, and then you get H there. OH. Is it okay? Everybody? Any other mechanism? Then, if you are okay with that, let us look at the next one also. Page එකත් බලමු අපි. We'll finish that as well. Huh? Yeah, we'll do that as well. හරි මොකද කියන්නේ? Right. So, well, pretty answers ටිකක් දෙන්න බලන්න. Like, give me some answers. Like, you have the toluene, CH3 attached to benzene ring. H plus KMnO4. What would you get? You get very easy reaction. You get C double OH. Then if you add lithium aluminum hydride H plus H2O, what will happen? It oxidizes, it reduces to give you CH2OH, benzyl alcohol. React this with PCl5, you get the chloride, benzyl chloride. Magnesium dry ether, you get MgCH2, MgCl. Right. React with PCl5, you get the acid chloride. And then you are adding D here. Right? Let us say it is added in excess. If you add it in excess, benzene and H plus H2O, you get OH here. And then this gives you CH2 phenyl, pH. pH means benzene ring. This is CH2 pH. Hari. Now tell me whether those answers you agree with that or disagree, whatever the things that you want to say onto this. Anything? Ken, Aaron, hey, come on, come on, come on. Wake up, wake up, wake up, children. Hey, right? Agree the, disagree the, what is your thought? Then before I say names, namkina Aaron, right? Right, okay. Right? Agree, right? Everybody agrees, sorry. Okay. Then let us look at the next one. Pyridinium chlorochromate. You get CH3, C double bond OH. How do you add HCN, sodium cyanide, and sulfuric? So you get CH3, COH, CNH, H plus H2O. What will happen? CN turns into C double OH. OH, this turns into C double OH and H. Anhydrous Al2O3, it will remove a water molecule. So CH2 double bond CH, C double bond O, OH. Hydrogen nickel, what will happen is double bond will break. CH3, CH2, C double OH. PCl5, it gives you CH3, CH2, COCl. Now you add benzaldehyde. This C6H5CHO means something like this. Benzaldehyde, it's a meta director. This attacks onto that. So now you get this compound. Benzene, C double bond OH, and this react with C double bond O, CH2, CH3. Now, Zinc-Hg, Conc-HCl, these are both aldehydes and ketones. They all undergo Clemmensen reduction. And that will give you CH3. On this side gives you CH2, CH2, CH3. Right. So this is your H. Hari, Kanabaland, what are your thoughts? Are the answers okay? Or you don't agree with some of those answers? Anything that you want to discuss there? Anything that you didn't understand? Huh? Yeah. Everyone? Okay. Right. Okay. Good. So you agree with the answers. Right? Hari. Very good. Huh? Then A. Now let us look at the third one. Only now the two questions. A. So COCl and benzene, you get C double bond O benzene. Right? Grignard reaction onto Grignard reaction onto pH named group in the first question last. pH is phenyl. Benzene එකට කියන තවත් විදිහක්. That is one way to say that. This is pH. ඔයා බලන්න note එක I given this. Right? In benzene, aryl compounds, I have given this. pH is another symbol that is used to say that it is benzene or the phenyl group. So CH3MgCl attacks onto this, breaking the bond. So you get OH, benzene, and another benzene. PCl5, same thing, benzene, CCl, benzene, and another benzene. KCN, if you look at D, and D, right? So all the things you get CCN, benzene, and benzene. D is that. H plus H2O, what do you get? It turns into a carboxylic acid. මේක SOCl2. ඕක තමයි ඔයා දැකලා නැති එක. That is also a chlorinating agent like PCl5. නිකම් මන් දැම්ම නිකන්. Right? Just for that. Right? SOCl2. And C2H5, NH2, it gives you a substituted amide. C double bond O. හරිද? NH C2H5. Benzene. This is this part. බලන්න හරිද කියලා. What do you say? Come on. Wake up. Hurry. Everybody? What do you think about those answers? Do you think anything that should be modified here? How can a benzene ring will be added when CH3MgCl? කොහෙද තිබ්බේ අපි CH3MgCl? It's CH3, no? Yeah. Okay. My mistake. Yes. I thought it is benzene. Yeah. CH3, right, yeah. මේක නේද කියන්නේ. CH3 is what is added. Yes. I thought it is benzene. CH3, These ones all CH3. CH3. මේකත් CH3. CH3. That's a good example where you have a cascading effect. එකක් වැරදුනොත් දිගටම කුඩු වෙලා යනවා කියලා පේනවනේ. Right? So need to concentrate. හරි. Okay, thank you. Thank you very much. හරි නේද? Now okay? Yeah, okay. Right. Fine. Others, any other disagreements here? Right. I hope not. Right. Then let us do the next one. Next one is you add concentrated sulfuric. You get CH3, CH, double bond CH, CH3. The method. Right. Then when you add acidic potassium permanganate B, right? B is equal to CH3COOH. It breaks from the double bond B, right? And then lithium aluminum hydride, it gives you C. C gives you CH3CH2OH. C. Then D reacts with PCl5, CH3CH2Cl. E is Grignard, CH3CH2 MgCl. CH3 MgCl. If you look at B, what is our B? React this with PCl5, you get F. F is CH3COCl. And what you do? E and F are reacted together. So let us say excess amounts and CH3, COH, and you get CH2, CH3, and then CH2, CH3, that gives you compound G. Haridhar, right. Okay. And I think that's what we planned. I think we have finished that. I'm sure you are tired also. Hari, next week, we'll try to do question number 5. Question number 5, 6, 7, 8, 5, there are a lot of conversions. We'll try our best to do, finalize the answers, will you? Question number 5, all these tutorials, and then try to finish that tutorial. Acid chlorides are over. There are 2 tutorials I need to give. We have to finish discussions. Like, you had the isomerism tutorial, most important tutorial, isomerism. I haven't given yet. And then, then we have to discuss this other thing is mechanism-based tutorial. We'll do that. We'll do that. That also will do. Because, we are, like, at the moment, you have a lot of material. So if I burden with you with lot of material, sometimes people don't do anything. Right. Okay. So complete them. Complete these tutorials, and then I'll give you another 2 tutorials, that is on organic chemistry. 2 tutorials, that is the isomerism and mechanism. All right. Going through all the mechanisms again, kapara balana, and isomerism questions. All right. Okay. I think that is, we'll call it a day now. Okay. Good night, children.